Hi everyone, this is Abra. Welcome to Abra Knowledge channel. Today I'm very excited. I'm going to talk about very important topic called 7QC tool. And this has been request from my few friends and they've been requesting me to make this video. I thought it's a fantastic idea to just make this 7QC. It's a well-known topic and I didn't discuss anything before on this topic, and I'm going to explore more on this topic and very interesting. I picked up a few examples. I picked up the case studies. I think this session is going to be very interesting, so please stay tuned. So before I could go ahead and do that, why do we need to learn that QC, right? 7QC we call it, right? Why do we need to learn that? QC meaning like quality circle. Why do we need to quality control? Sorry, quality control. Why do we need to learn it? So basically, it gives an ability of problem-solving techniques. You know, when we have a problem-solving technique, we can deal in whether it's a personal problems or professional problems. So we can just resolve it. We will have an ability to see things in different spectrum or different perspective. That's one of the reasons why we need to learn the art of problem-solving techniques. So in any every industry follows it, whether it's automotive, whether it's medical and aerospace, every industry follows it. It's a well proven technique, and it's good to have. So one the flip side, the positive side of this coin about problem solving technique is it will avoid the blaming culture. Just to start that, since I'm talking about the quality control, I just wanted to, for a minute, I just wanted to go off the topic and come back to 7QC tool. And it says like in the beginning there was a era like where very everything, whenever the mistake happens, whenever the error happen, whenever anything goes wrong, the human, the pressure is on human actually. This is because of this person and that person, and it was everything all about the blaming culture. And then this established tool came and said, no, we should not blame people. Beside man, there will be another, there are other factors which can contribute for the problem. We'll talk about more in cause and effect diagram. Yeah. So this is the 7QC tool. One is check sheet. We'll talk about what is check sheet, and then the second tool is Pareto diagram. Pareto diagram, or the third one is cause and effect. It also known as Fishbone diagram, and then you have a graph, histogram, scatter diagram, and stratification. So these are the seven tools which we will be talking about today. So check sheet, actually, you all know that check sheet, right? It's basically whether it's you have a continuous data, that is measurable data, whether you have a discrete data, like countable data. In both the cases, you can use a check sheet just to ensure that everything is okay. One typical example, you can use it, for you have a maintenance sheet. You wanted to check whether the this particular machine has been validated, has been maintained, or has been checked, has been cleaned, has been all of these things. I think check sheet we can very well use it. So any data, whether it's both the thing continuous and in a discrete data, you can very well use check sheet. Basically checking, you have a CTQs, critical to quality, and you're just checking whether it's been done or not. So, and then you can also, while making the check sheet, you can also write it down, the purpose of the check sheet, because, what is the purpose? For example, you have a machinery, and why do you want to do that? That's a small purpose. We can write it down, and which item number, which, what is the ID number for that particular machine, so that you can also cross verify whether you have done it. As if we can consolidate the file, you will get to know how many machines have been has been checked and all that. In order to have the log, you can just do that. And method, what method you use it, you can just brief about it, and the date and time of this one, and the person who has done that checks also can be written down, and the results also as well. So this is one typical format for defect one. For example, let's say you have a component, and then these are different dates are coming up, and you have a different thing. You can put it like 1, 2, 3, 4, and 5 and so on. So this is one way of doing it. Not only you can use for discrete data, you can also use for any measurable data also as well. Okay, before I go and talk about the, there is something called cause and effect diagram. I wanted to quickly pin up a point about brainstorming. Because brainstorming, any cause effect diagram, whether it's a YY analysis you have, whether it's a fishbone diagram you have, one paramount important thing is you must need to know, you need to have a balance and well balanced CFT, cross function team. We'll talk about more about it. So there is why brainstorming is required. Brainstorming, like different people are coming together, sharing the idea. For example, the problem happening in manufacturing, the design guy, manufacturing guy, and you have quality department. Everybody sit together, discuss the problem, what went wrong, and discuss about what is the critical causes which could have which could have contributed for the problem, and find the solution and prevent the problem. So there are three methods actually. I'm just wanted to go a little quickly on brainstorming because it's not part of 7QC. In order to establish and set the context around, fishbone diagram, I picked up this one. There are three things here. One is structure, unstructured, and you have there is called slip method. The structure method is also called Robin method. Where, for example, you have a CFT, cross function team, where a problem happened and you have a five people or four people you have, and one person need to give his or her idea what could have gone wrong, another person, and then followed by third person, followed by fourth person. This is called round robin. Yeah. Unstructured one meaning like anybody can raise up the hand and give the idea. For example, let's say it can be on the board, it can be anybody can raise the hand and say, yeah, so this could have contributed for the problem. So this is third one is called slip method. We will talk about that. Slip method is also one important thing. Where we also need to talk about the, we need to write it down and then say and then pin up on the board or something like that. Or you can give it to the person who is consolidating the file. We can give it and all that. This is also like unstructured method. But actually like writing down and then pinning up and everything. So you will have a consolidated view like what is the thing, what is the outcome of what the person believed that is the cause for that problem. So while brainstorming is the input to any problem solving. So that's the reason I'm emphasizing more on the problem solving technique on the brainstorm and the brainstorming one. So every idea we need to take it. So there is something called wild ideas. You don't need to validate whether the idea is the real cause of the problem or not. You can pick it up all these issue and then you can just you can talk about the quantity in this particular event. You can talk about the quantity. Every idea you can just do that and write it down, respect everyone's feelings and all that. So that is brainstorming. So for that, you can use, there is something called Pareto diagram. Pareto, you all know. This is 80-20 principle. The person who invented this concept, Wilfredo Pareto, was Italian and he was the economist and who was invented something called Pareto analysis. Very interesting concept. 80 percentage of the people own, 20% of the people own 80 percentage of country's wealth. So that means I will pick another one. 80 percentage of the people own 20 percentage of country's wealth. So let me take another example. So your few causes can lead to many defects. The causes can be simple. Maybe few, which can contribute for the many defects. So many causes lead to few defects. So we'll talk about this is something called vital few, trivial many, and all that. So how to do that one? This is 80-20% principle, right? So first we need to collect the data and we need to arrange the data in ascending one sorry, descending one. The big to small, we need to pick it up, and then we need to put that. Maybe I'll quickly go here. So let's say this is your file, and this is you wanted to basically identify the phone calls which being made. Let's say external phone calls. So these are all the departments you have on the column B, and these are all the number. And you need to keep the data from big to small. Yeah, all these number you need to put it, and then this width you will get the sum of value. This sum of value against each one you need to divide. For example, let's say 66 by 200, you will get a percentage, and then you will keep having this percentage. This percentage, you will just find it like aggregate percentage. For example, let's say you have something 33, 33 plus 25, 55, 55 plus 6, 10, 65, and so on. So this is something to find like proportional. So this is the typical graph you will get it. So basically you don't need to focus all 10 department. You can focus only on material, marketing, plant maintenance, and partly I will also will focus on my finance department. So this is something, you will get an idea like which are all the things you can focus on. So that is the another example I already shared in the YouTube also as well. I made a one exclusively video on Pareto. This is something the same example I picked up once again. For example, you have these defects coming out from the laptop, and these are the secondary causes you have, and then you have quantity, and then you can just convert the same thing. 95 by 90 you will get the percentage. This cumulative percentage you can find out. This is what you will get the Pareto. So that means ideally you will focus only these three big pictures, so that you will be able to resolve any problem. So 80 20 principle in summary. That's a very powerful tool called Pareto 1. So another one is called, I'm going to the third tool called cause and effect diagram, or cause and effect. First, we will understand what is cause. Cause meaning like effect is a result of an outcome, right? Effect is what happened. For example, this, you can see that, this wheel has punctured. So this is effect. Why that wheel is punctured? Maybe because of the needle which could have pricked, or it could be another factor also as well. So this is the typically fishbone diagram. So 1953, this is the Koro Ishikawa is the person who was a professor who found this one. And basically, cause and effect, you can also say like fishbone diagram, man, machine, method, material. You can jerk it down all these points, and then you can write it down whether it's a probable cause, improbable cause, and all that. You can write it down. For example, if the things are coming from right to left, that's called probable cause. The chances of that is high, and if this coming from right to left, that means chances are low. So like you can also categorize that way also as well. So you can write down the main problem here, and then causes here. For example, here you can write down the effect, you can write down the causes. So, for example, let's say you have a dimension variation is there. So, let's say if you put into the paradigm called man, maybe because of the fatigue, because of the health. Even in health, there are two things: fatigue and illness. Even in skill training and experience, like this, you can keep accumulating all these factors which could have contribute for that particular effect. This is another example. Let's say not only we can use it for fishbone diagram. This is common misunderstanding. Fishbone is not only to use it reactive way, meaning like when the problem happens, go and find out this one. We can also use it for proactive approach also, for proactive approach also as well. For example, let's say error free document I wanted to make. Let's say take an example of environment. So environment, right time of the day, no interruption should be there, and good economics should be available, timelines I need to make, and all that. This is also we can use it from the proactive approach side also we can use it. So next we're going to talk about the graph basically gives an indication that what is the trend, whether the trend is linear, non-linear, and so on. Why do we need a graph? Because the number, whatever you depict in the picture, it speaks more louder than the words, right? So that's the reason we need to have a graph. So, and then I'm just going back, and the graph is very simple, just to depict like whether there is a bar chart, whether how things, I mean, how the trends is all about, whether the trend is going in linear or non-linear, whether the trend is staked one, and all that you can figure out. That is one effective way. Anything you do analysis, you convert into graph, you will get, anybody can just understand by looking at this thing whether things are going right, or whether the things needs an improvement, everything you can find it. There is called histogram. Histogram is also very interesting diagram. I mean, very interesting concept. There's that and one of the six core tool. I mean, 7QC tool. This is the sixth one, histogram. It talks about the total item under consideration is called. There is something called population. So let's say you have a you are making thousands of product, and in that now which product has got a defect. Now that we'll talk about more about this one, how the sampling can be carried out. So, for example, considering a sampling inspection, we take a sample from a lot, carry out the measurement on it, then decide whether we should accept the whole lot or not. Here, here our concern is not the sample itself, but the quality of the whole lot. For example, let's say you have two lot. One lot is 1,000 quantity, another lot is 500 quantity. Out of 1,000, let's say you took 1% of it. Let's say you took thousands, and out of 1,000 you took 10 and then you're just inspecting it and you didn't find the problem. So another one you took it, another actually out of 500 you took again the 1% one. Roughly you took five samples one. In the five sample, one problem you found it. So that means actually sometime it is a risk actually, like you how to redo everything and all that. So there's something called you have a data and you have a fact, how you can interpret. There is something called, I wanted to quickly talk about this one. This one, there is something called correlation. Let me use it. Okay, before I go and show it, and this is let's say your because your two things should be same. Your sample should be same. Whatever you're discussing it has to be the same one. For example, you cannot compare. For example, laptop as a whole, you cannot compare with the charger. If you wanted to compare the entity called charger, you need to compare with the charger against charger. If you wanted to compare laptop, you need to compare against laptop versus laptop, something like that. So let's say this is the observation, these are the dates and these are the observation and this is the defective percentage. So basically what when you put the scatter diagram, basically it will give like how that your trending is all about. How, for example, on the data of these are all the result you got it, where the plot is coming across. This plot, there is something called, you can also put it like percentage everything, and then there is something called positive correlation, negative correlation. Positive correlation meaning like you have a linear one, and negative correlation meaning like, so linear meaning like both things are proportionate, meaning like directly proportionate, meaning like when the number of samples are increasing and you have number of defects is increasing. So another case is actually you have a number of items and the defects are reducing. So that is called positive correlation. And if the things are happens in the reverse way, one is increasing, one is decreasing, then you call negative correlation. Positively, this is the one maybe present. Negative, this is the one. And for example, if it is scatter diagram, if it is spread across, there is called scatter, right? So that means you will not be able to make out. You cannot say whether whether if the quantities increase, your number of errors are increasing. You cannot say. You cannot also say that if the quantity is increasing, a number of errors is decreasing. So that is called scatter diagram. First we need to find out what is the trend is all about, whether it's a linear one, whether it's a non-linear one. So just figure out what is the seventh QC we talked about. So far we covered up sixth one, and the seventh one, can you have any idea? Take a guess, please comment if you get an idea, like what is the seventh QC tool. The seventh one is stratification. Stratification is more or less like a scatter diagram. The only thing is here we compare with multiple things. For example, let's say three machines I can compare with the same thing, versus input and output. You have three machine, I'm just comparing it. Then we can use stratification. It's just a little advanced. Then the scatter. Scatter is you have one is to one. Yeah. Here you can compare three things together. When data comes from the several sources or several conditions, shift days of week and suppliers, populations. When you have anything, when you have a multiple factors, you can use stratification. So I just wanted to make a conclusion. So this conclusion is on my reflection. Whatever you have learned, put up in writing. It will well register your mind. Number thing, take 3 minutes. For example, if after watching this video, just talk about, okay, what did we learn in Pareto? What did we learn in check sheet? What did we learn in cause and effect diagram? What did we learn in stratification? What did we learn in scatter? What did I think you can put it that way, and consider your own way of writing or working. Write down 5 things about way of working that will improve the future. For example, like how we're going to implement Pareto, how we're going to implement stratification, and so on. Put this list somewhere you can see it to remind you. So that's it from my side. If you wanted to connect, this is my number. And if you wanted to connect in LinkedIn, Abrar Knowledge One. And this says please do like and share and subscribe my channel, Abrar Knowledge. So thank you so much, and you have a nice day ahead.